Every time before exam, most of you may spend hours on revision. You're always confident before the exam. However, sometimes you know everything, but in the exam, you can just answer something. You are not stupid, but slow. Take a question as an example. In a one-dimensional elastic collision between two balls, we know that both the total momentum and the total kinetic energy of the balls are conserved. Usually, we will then have to solve these two equations. In a real question, what a mess. In fact, there is a shortcut. Let me derive the shortcut method using an example. Suppose there are two balls of mass, m1 and m2, moving to the right at constant velocities, u1 and u2 respectively. The red ball hits the cyan one, and they eventually travel at v1 and v2 respectively. The total momentum of the balls is conserved. So, initial momentum of ball 1 plus the initial momentum of ball 2 equals the sum of the total momentum of ball 1 and ball 2. Now, we can factorize the equation. Move the terms with m1 to the left, and move those with m2 to the right. Now, we have obtained this equation. Let's copy this equation to the top right corner, and call this equation 1. We will use it later. Apart from the total momentum, what is conserved in an elastic collision? The answer is the total kinetic energy. Note that kinetic energy of a body is 1/2 times mass times the square of its speed. The left-hand side of the equation is the sum of the initial kinetic energy of the two balls. The right-hand side is the sum of the final kinetic energy of them. As both sides are multiplied by 1/2, we can just eliminate it. Now, let's factorize the equation. First, move the terms with m1 to the left, and the terms with m2 to the right. Then, obtain the common factors. Okay. So far so good. Next, expand these two underlined terms using this algebraic expansion formula. Trust me, this formula is correct. You can plug in any numbers into A and B. Alright. After expanding, the equation becomes this. Now, can you see that this is the same as this? From equation 1, this term equals m2v2 minus u2. So, let's replace with m2v2 minus u2. Now, can you see anything special here? This is common to both sides, so we can just eliminate it. Now, we have got this simple equation. What does it mean? It means the sum of initial and final velocities of ball 1 equals that of ball 2. As we have got this simple equation, we don't have to solve any equations with squares now. With this shortcut, you can solve a one-dimensional momentum question in seconds. How can we use it? Let's use the same example with numbers this time. The mass and initial velocities of the balls are known. We have to find the final velocities of the balls. First, we use the equation for the conservation of total momentum. The initial momentum of the red ball plus that of the cyan ball equals the final momentum of the red ball plus that of the cyan ball. So, we have got this equation now. Then, we use the shortcut. The sum of the initial and final velocities of the red ball equals that of the cyan ball. So now, we have got another equation. Substitute VR equals VC plus 1 into the previous equation. We find that VC equals 1.2 meters per second. How about VR? VR equals 2.2 meters per second. That's all. To learn some more legal cheating skills, like and subscribe.